Hi everyone, this is SurfOutLoud. It's a collaboration site just like Slack, for example. My name is Per Lindquist, and I have done this together with Peter Wenström. As I said, it's a collaboration site, and I'm going to walk you through a short demo of our application, and then Peter is going to show us some technical implementations within the code. But for a starter, I would like to talk a little bit about what kind of tools we've used. For example, we have used Vue.js as a client framework. As a client-side routing, we've used Vue Router. HTTP client is Axios. State management is Vuex. And as a build tool, we used Webpack and Vue Loader. For the server framework, we used Flask, which is implementation is a framework in Python. And as a database, we used MySQL, and real-time engine is Socket.io, which in Flask is called Flask Socket.io. We also deployed it on a web server called Heroku. So as I said, this is the login page where I can log in to my account. And as you can see, I've just entered the dashboard where all of my project is, where I'm currently involved in. So for this screencast, let's create a new project called screencast project. This is a description of a screencast project. Let's make it a space there. So add members, what about Johan and Oompa Loompa? And then add a beautiful icon like this star, and maybe this green. I like green. So create project. So as you can see, I'm getting redirected to the project view, where only I am as a member at the moment because the other one hasn't accepted it yet. So this view is having three kind of components in it. It has the member component, the chat component, and the file component. So let's demo the file component, for example. I can choose to upload a file like this, for example, and then it's added to my Dropbox account. We have implemented the Dropbox API as the file server system. Everyone in this project can preview it, as well as download it and delete it. Let's go into a multiple view. I have now entered the multiple view where Persa is logged in to the left and Johan is logged in to the right. As you can see, only Per can see the Persa can only see the screencast project because Johan hasn't accepted it yet. So let's do it. Go into Johan's profile, look for the project invites, and you can see the screencast project has been invited by Persa. Let's accept it. We go back to the dashboard, and we can now see the screencast project. Let's go into it. For now, you can see members has gone to 2, and Johan is currently active. Persa is not, because he's not in the project yet. So if you go into the Persa side, you can see both of them are online. So for now, we can chat with each other. And then chat back. If we are multiple members, there is also the functionality to send direct messages to each other. So, for example, if Johan want to send a direct message to Persa, he could just click my name, and then a window has opened. And both of them can chat with each other without disturbing the other member participants. So, for example, you can see in the room there's still the history of the global chat here, or the project chat. Both of them can see both files, one file. Both of them can preview it, and both of them can download it. It's pretty simple. All right, I think that was all for now. I can show you the deployment and where you can do it yourselves. Here you now have the deployed version of our app. It's in surfoutloud.herokuapp.com, and here you can register and create an account and see for yourself what this app is about. Thank you very much, and I'm going to now head over to Peter's side, where he will show us the technical implementations, or some of them at least.
Alright, so now we're going to take a closer look at some technical aspects of the application. First, I'm going to talk a little bit generally about our setup and tools. Then I'm going to quickly try to show what Vue.js is all about, as many might not be familiar with the framework. I'll especially show what a Vue component is and how it typically is constructed. Then I'll move on to talk about a couple of issues we've had, as well as some things we found especially helpful or interesting while developing the application. Per mentioned some of the tools we've used in the beginning of the screencast, and as you can see from our package.json file, we have quite a lot of dependencies, so I'm naturally not going to talk about all of them. As mentioned, we've used Webpack to bundle the application, and we've used it together with several different loaders. For example, we've used Babel loader to transpile into JavaScript, mainly to enable the use of ES6. We've also used the Vue loader to enable us to write our Vue components in a certain format, which is really nice, and something I'll be showing you soon. Now, some of these things were provided for us from the start, since we used the boilerplate to get us started quickly. But generally, Vue is a modular framework. That is, you have to add things as you go along rather than everything is included on the initial install. For example, we had to add and install Vue router to enable client-side routing, and we had to install Axios to get an HTTP client, and the list could go on to more specific components that we've added manually. So the downside is that you have to search a lot and install things as you go along, while the upside is that you generally get a very lean app with things that you really need and that you really use. So let's have a look at the Vue component in our project. This is the project invites component. As you can see here and in the list of components to the left, Vue components have their own file name extension, .vue. Now, the nice thing, at least to us, is that the whole component is written inline and is divided into a template section, a script section, and a style section. If we start by looking at the script section, you typically have import statements to begin with. Here, for example, we are importing Axios to enable the component to make HTTP requests. Then there is an export statement where the component's options object is defined. We have a data property where the data model is defined. We have a props property where we define what properties we are expecting the parent to pass into this component. Then we have a methods property where functions can be defined and later called upon from within the component. Lastly, we have the created property, and this belongs to the component's lifecycle functions. There are other functions like this called before create, before destroy, and destroyed, and they run at specific times in the component's lifecycle, which really helps a great deal when designing your component, especially the timing of things that you want to do. The style section isn't that interesting in its own. One thing worth mentioning is this scope keyword. It specifies that all CSS written in this section will only affect HTML elements that are specified in this component, which is really, really helpful in many times. If we take a look at the template section instead, the nice thing in comparison to, for example, React, is that you can write pure HTML in here. and you don't have to worry about JSX. People used to Angular might recognize the use of directives, vif and v4, for example. And these are pretty much smart markups that tell the Vue library to do something special right here. In this case, it says vif error. It says pretty much what it means is show this element if error contains something. And v4 is pretty much saying do a for loop and iterate through all the objects in the projects array. Lastly, this is how you output variables in your HTML with the double curly brackets delimiters. And this was actually one of our first issues that we bumped into, where we couldn't even get the app to render at all. And it turned out that it was because Vue and Flask's template engine Jinja used the same delimiters, which pretty much broke the whole application. So what we needed to do was specify Flask to use different delimiters. So here we are specifying that Jinja is supposed to use $$ instead. But that was pretty much all I was going to show you in those terms. The next thing I was going to talk about that we've spent a fair amount of time on is state management. We noticed pretty early in our project that it became a pain passing properties and emitting events all the time to keep the components synced when it comes to the state and the data. So we decided to use Vuex, which is a state management pattern and library for Vue applications, which is heavily inspired by Flux and Redux. The main idea is to keep a centralized store for the application and access data and control the state through that store. If we take a look at the code here, we can see that the store imports 2 modules at the moment, and I'm going to show you the user store module. This is simply where we store some information about the current user. The store module is divided into state, getters, mutations, and actions. The state is where the data is declared and also given an initial value. Now the only way to access this data is through the getters. And what they do is simply return the current state of the specified data. For example, here we are returning the user object, which contains an access token and a username. The only way to change the state in the store is by committing a mutation of the store. And this is pretty much the only thing a mutation can do. It can only edit the current state of data. But Vue components themselves can't call mutations. Instead, actions are used to commit mutations. And actions differ in the sense that they can also do more complex logic, for example, asynchronous functions or asynchronous operations. Right here you can see that the actions are pretty clean, and that's because we've decided to put most of the business logic in a separate file, which I'll show you here. So this is where we do the asynchronous operations for logging in a user, where we make an HTTP post request to the server, and on success you can see that we dispatch an action to the store, and this is how we actually use an action. Just a side note, you can see right here that we use arrow functions. This together with something called destructuring assignments, which you can see right here, is pretty much what we used ES6 for, which I mentioned in the beginning. But that was pretty much all I was going to say about state. The last thing I'm going to talk about is our implementation of the chat service using Flask Socket IO. So this is the chat component that we're looking at right now. The chat component is one of our messiest components, and it could probably use some refactoring at this point. The complexity grew quite a bit when we added direct messaging on top of room chat. But anyway, this is basically how it works. First off, the socket IO client is imported right here. Then what we essentially do is we make a connection to the server when the component is initialized right here, and when the component is fully created, if you remember the lifecycle functions, what we do is we join a room through this function, and then we set up a bunch of event listeners. So if we take a look at the join room function, what it does is that it emits an event called join to the socket, where we also add some information about the user and the room. If we take a look at the server side, it is also basically a bunch of event listeners that watch for certain events being passed through the sockets. But here they are using decorators instead. If we take a look at this function right here, you can see that the decorator is listening for the keyword join. Then this handler function is called and takes care of some logic, and then it ends by emitting an event of its own called join room response. So if we move back to the client again, we can see that we have a listener on the client side listening to that specific event, join room response. So when it sees that such an event is emitted, we can do something with the information that is emitted. In this case, we are pretty much just emitting the information that is passed from the server to the parent component. It's a bit confusing that this is called emit and this is also called emit, but this is emitting information to the socket, while this is emitting information to a parent component in the view application. And this is pretty much how it works, whether one wants to join a room, leave a room, or send a message in a room. And we think that the use of Flask Socket IO has been really smooth in general. One issue we had though was that we wanted to install a library to enable WebSocket transport, which is pretty much just a better performance than you get otherwise. So we installed a library called Eventlet, which was widely recommended, and to get that working we started the server with G-Unicorn. And it worked great on our deployed server, and also for Per, who was working on a Mac. But since there's no support for Windows for G-Unicorn, it turned out to be pretty much a dead end for me, since I'm working on a Windows machine. We tried a couple of different HTTP servers apart from G-Unicorn, but we didn't succeed with any of them. In the end, we solved it simply by uninstalling Eventlet in my local environment, and I kept working using long polling instead of the faster WebSocket transport. And it was fine to work with, but it was slightly frustrating that you couldn't find a solution for it. So that was pretty much all I was going to talk about. Thank you for listening, and feel free to check out the deployed version.